Okay, so this is for geometry, section 4.2, congruence triangles. All right, geometry up here. And there are actually 7 boxes of this lesson, so quite a bit. But I'll try and 7 boxes here and try and get you through it. Okay, so the first box is talking about congruent figures. So congruent figures means 2 things. It means same shape, same size. So check it out. I've got 2 triangles over here. They are the same shape. They are the same size. Therefore, they are congruent. Number 2, if 2 figures are congruent, then you can say a lot about the figures. So let me tell you exactly what you can say, right? First, let's talk about their sides, right? I can say that AB is congruent to EF. So I can say AB congruent to EF. Number 1, right? I can also say BC congruent to FG. So number 2, BC congruent to FG. These are all line segments over here, right? I can say number 3, CD congruent to GH. So I can say, last I can say DA congruent to HE. So I can say all 4 sides are congruent. Look at all these things that I can say just about the sides. Now I can do the same thing with the angles. I can say angle A is congruent to angle E. I can say angle B congruent to angle F. Angle B congruent to angle F. I can say angle C congruent to angle G. Angle C congruent to angle G. And I can say angle H congruent to angle D. So angle H congruent to angle D. So look, I can say 8 things about this particular figure if I know that they are congruent. So all the sides are the same, all the angles are the same shape, same size. Okay, number 3, here's an example of this, right? I have 2 congruent figures, right? I just copied one and then rotated it. So if I know they're congruent, I can say a lot of things about them, and I can solve for the variables. Those are the directions here, right? It doesn't tell you that. It says solve for the variables, x and y. So I want to solve for this one up here, 8m and 2x plus 3 times m, because I know that BC is congruent to GH, so I can set those 2 things equal to each other. So I know that 8m has to be the same thing as 2x plus 3 times m. And then using algebra, I can see the m's cancel out. So 8 is equal to 2x plus 3. So subtract 3 from both sides. I get 5 is equal to 2x. Therefore, x must be equal to 5 divided by 2, which is 2.5. There we go. So I figured out what x is. Now I can do the same thing to figure out what y is. Okay, so I know that angle D here is congruent to angle E, so I can say that 89 degrees, or 89 must be equal to 7y plus 9. Therefore, I can know that 80 is equal to 7y divided by 7 divided by 7. Y must be 80 over 7. You can leave it in fraction form if you want to. So, if I know 2 figures are congruent, I can say a lot about their sides and their angles, and I can use that to solve for different variables. The third angles theorem, box number 4, we want to make sure that we put this one into our toolkit, and my toolkit is online, so you can grab it from me, but I'll show you the toolkit that we're supposed to have here. So, we'll go to View, Normal, Geometry. So, in my toolkit, right, I'm already on the 2nd page. Notice I put the third angles theorem in there. It's from section 4.2. And make sure that you copy that into the toolkit. Okay, so let's bring you back over to the lesson here now. Alright, so basically what the third angles theorem says is this. If you have 2 congruent triangles like I do here, right, if angle A is congruent to angle D, and angle B is congruent to angle E, well then the third leftover angle has to be congruent. So here's what it says. If angle A congruent to angle D, B congruent to E, then angle C has to be congruent to angle F. It's just by leftover pieces, right? So if you know the first 2 angles are the same, then the third one has to guarantee to be the same. That's the third angles theorem. It's really important. All right, so we're going to use the third angles theorem right here. So if I know that triangle ABC is congruent to triangle DEF, How can I find the value of x? Okay, so here we go. I know that this angle is 55 degrees, this angle is 65 degrees. So therefore, the leftover piece up here, right, has to be 180. Take away 55. Take away 65. So that leaves you with a 60-degree angle up here. So I know that this is 60 degrees. Now, I know that angle B is congruent to angle E by the third angles theorem, so I can set 60 equal to 2x plus 30. If I subtract 30 from both sides, I get 30 equals 2x, therefore x has to be 15. So using that third angles theorem comes in handy if you know two figures or two triangles are congruent. Okay, then in the class, what we did was we took a break, and then we had some classwork from page 205, numbers 1 through 9, so make sure you get all that done. Then after that, we came back, and we had 2 more boxes to finish up. And number 6 was proving two triangles are congruent. Okay, and the way to do it, in order to prove that two triangles are congruent, you have to show two things. You have to show all 3 sides are congruent and all 3 angles are congruent. So those are the 2 things you have to do. And right now, what we're going to do in this problem is we're going to prove, given the diagram, we're going to prove that triangle PRQ is congruent to triangle NMQ. Triangle NMQ. So in order to do that, I got to show all 3 sides and all 3 angles, right? So, okay, I've set up my my 2-column proof here for you. So step number 1, look at all the diagram. I can see a lot of things, right? I can say that PQ is congruent to NQ. I know that RP is congruent to MN. And I also know that RQ is congruent to MQ. And all of that has been given to me from the diagram. And all 3 of these are 3 sides. Would you guys agree with that, right? So I have shown that all 3 sides are congruent in my proof, right? Okay, number 2. I know that angle P is congruent to angle N. And because that's also given to me, right? And that counts for an angle. Okay, I need to show the other 2 angles are congruent here, right? So number 3, can we say that angle PQR, which is this angle here, right? Angle PQR has to be congruent to angle NQM, which would be this angle over here. I'll do it in pink so you guys can see it, right? NQM. Now, why is that true? Angle NQM. Hopefully you guys realize that those 2 angles are vertical. So that's another angle I have shown, right? So that's another angle. So far I have all 3 sides and 2 angles. So if I could get the other angle, if I could show that the other angle is congruent, I would have enough to show that my 2 triangles are congruent because I would have shown all 3 sides and both angles. So the only other angle I am missing here looks like is angle R over here in this corner and angle M over here in that corner. So is there anything that we could figure out that we could use to show that the third angle is the same? Well, of course, we're going to use back up here our third angles theorem. That says that if I know 2 triangles are congruent, then the third has to be congruent. So that's going to be my reason. So now I can say angle R is congruent to angle M. That's another angle. And that's by the third angles theorem. Alright, so check it out. I have shown all 3 sides, and I have shown all 3 angles. So therefore, I have enough information to say triangle, what was it again? Triangle up here, PRQ is congruent to triangle NMQ. And that is the definition of congruent triangles. Alright guys, there you go.